Hello friends, I welcome you all on my YouTube channel Rasayan Setu. So friends, in today's video, we are going to discuss previous year questions of physical spectroscopy and term symbols which was asked in CSIR NET June 2019 exam. Okay, so let's start. Now see, this is your first question and it says the correct statement about HCL and DCL among the following is, and we have a four option, that is DCL has a smaller 0 point energy than SCL, SCL has a smaller vibrational frequency than DCL, the force constant of the SCL bond is half of the DCL, and the fourth option is the reduced mass of DCL is smaller than that of HCL. Okay friends, so friends, we have four options and we must choose the correct option out of these four options. Okay, and this question is coming for 2 marks. So let's do the solution of this question friends. Now see, this question is coming for 2 marks. Okay, now first of all, we know that the formula for finding reduced mass for any molecule is reduced mass, that is mu, is given by m1 into m2 upon m1 plus m2. This is a formula for finding reduced mass for any molecule. Okay, for example, when we must find the reduced mass of HCl, that means here the m1 should be the mass of hydrogen atom, the m2 should be the mass of chlorine atom, and here m1 plus m2. Understand? Okay, so that means the reduced mass of HCl is equals to mass of hydrogen multiplied by mass of fluorine divided by mass of hydrogen plus mass of chlorine. And similarly, the reduced mass of DCl will be given by the mass of deuterium multiplied by mass of chlorine divided by mass of deuterium plus mass of chlorine. Okay, and friends, we know very well that mass of deuterium will be equals to 2 times mass of hydrogen. Okay, the mass of deuterium will be equal to 2 times of hydrogen. So let's put the value of this mass of deuterium into this reduced mass of DCl. So that means your reduced mass of DCl will be equals to 2 times mass of hydrogen multiplied by mass of chlorine upon 2 times mass of hydrogen plus mass of chlorine. Okay, now let's take the ratio of the reduced masses of DCl and SCl. So when you take the ratio of reduced mass of DCl and SCl, what we get? See, the reduced mass of DCl is 2 times Mh multiplied by mass of chlorine upon 2 into mass of hydrogen plus mass of chlorine multiplied by mass of hydrogen plus mass of chlorine upon mass of hydrogen into mass of chlorine. This is a simple calculation friends. When you take the ratio of reduced masses, then this expression will come out. Okay, now let's do the when you solve this equation, we get what? See, 2 into mass of hydrogen plus mass of chlorine upon 2 into mass of hydrogen plus mass of chlorine. Okay, this is the ratio of reduced mass of DCl and HCl, that is 2 multiplied by mass of hydrogen plus mass of chlorine upon 2 times 2 into mass of hydrogen plus mass of chlorine. Now when you solve this equation, so you will definitely get the value will be greater than 1. Okay, when you solve this whole expression, when you place the values of hydrogen and chlorine respectively, then this whole value will definitely come out will be greater than 1. Okay, this whole value will be greater than 1. So it means the ratio of reduced mass of DCl, the value of the ratio of the reduced mass of DCl and HCl will be greater than 1. So that means your reduced mass of DCl will be greater than your reduced mass of HCl. Understand? This is a first relation. Okay, so reduced mass of DCl will be greater than your reduced mass of HCl, and so that's why so from this result we conclude that your option number 4 will be wrong. That says that, see in the corner, it says that option number 4, the reduced mass of DCl is smaller than that of HCl. but here we conclude that a reduced mass of DCl is greater than that of HCl. Okay, so your option number 4 will be wrong. Option number 4 will be wrong. Now we left 3 options. Okay, now the first conclusion this, okay, the reduced mass of DCl is greater than HCl. Now we have a formula for vibrational frequency. In spectrum, the formula for finding vibrational frequency, that is mu, is equals to 1 upon 2 pi under root k by mu, where k is force constant and mu is reduced mass. Okay, this is the formula of vibrational frequency, and by this formula we conclude that your vibrational frequency will be inversely proportional to under root of reduced mass. Your vibrational frequency will be inversely proportional to under root of reduced mass. That means the molecule with higher reduced mass will have lower vibrational frequency. Okay, the molecule will have higher reduced mass will have lower vibrational frequency, and in this point we conclude that your reduced mass of DCl will be greater than HCl. That means the vibrational frequency of DCl will be less than vibrational frequency of HCl. The vibrational frequency of DCl will be less than your vibrational frequency of HCl. So this is the second conclusion. Okay, now on the basis of this conclusion we conclude that your option number 2 is also incorrect. That says that HCl has a smaller vibrational frequency than DCl. Okay, but here you conclude that HCl is higher frequency than DCL. Okay, so from this conclusion you also concluded option number 2 is also a wrong answer. Now we have only 2 options left. Okay, now the formula for 0 point energy is, the 0 point energy is equals to that is E, half h nu. This is the formula of 0 point energy, that is half h nu. Okay, and from this formula we conclude that your 0 point energy will be directly proportional to the vibrational frequency. Okay, the 0 point energy will be directly proportional to vibrational frequency. That means the molecule with higher vibrational frequency have high 0 point energy. Okay, so here we conclude that the vibrational frequency of DCl is less than vibration frequency of HCl. So from this conclusion we also conclude that the 0 point energy of DCl is less than the 0 point energy of HCl. Okay, the 0 point energy of DCl is less than the 0 point energy of HCl, and this is the another conclusion. And on the basis of this conclusion we conclude that your option number 1 is the correct answer. That says that DCl has a smaller 0 point energy than HCl, and here we prove that DCl is smaller 0 point energy than HCl. Understood? Okay, so it is your option number 1 that is correct answer. Your option number 1 is the correct answer for this question. Understood? Okay, see once again the whole solution. This is generally a formula based question, friends, and again a very simple question, friends, and it is asked for 2 marks. Understand? Okay, now we move towards our next question, and see it says the allowed transition in an atomic system is, and we have 4 options. Okay, so out of these options you must find out what transitions are allowed. Okay, and this question is also coming for 2 marks. Okay, so let's do the solution of this question, friends. This question is coming for 2 marks. So for allowed transition, friends, we have some selection rule. That on the that selection rule decides the criteria that that the given transition is allowed or forbidden. Okay, so we decide on the basis of selection rules. So what are the selection rules for any transition, for any possible transition? That selection rules are, see, selection rules are, first of all, the difference in spin multiplicity will be 0. The delta S should be 0. Okay, this is the first selection rule. Now the next selection rule is the difference in L should be 0 or plus minus 1. Okay, we have a general expression, see, 2s plus 1 Lj. Okay, this is a general expression for any term symbol. Okay, 2s plus 1 Lj. So delta S should be 0 for allowed transition. Delta L should be 0 or plus minus 1, and delta J should be plus minus 1. These are the three selection rules that decides that given transition are allowed or forbidden. Okay, so we have four choices. So you must apply these selection rules on your given options, and which option, and those option which satisfy all the selection rules or condition, that means those option are allowed, those option are allowed transition. Okay, very simple. Now we take option number first. So option number first is the 3f4 to 3d3, 3d3. Okay, first transition is 3f4 to 3d3. Now here you see that here the value of 2s plus 1 is 3, and here also the value of 2s plus 1 is 3. So that means here the value of delta s will be 0. The first condition will be satisfied. Okay, now another condition is delta L should be 0 plus minus 1. Now here you see that the value of L for F term will be 3, and the value of F for L term will be 2. So it means here the value of delta L is 2 minus 3, that is minus 1. This condition will also satisfy, that is delta L will be 0 or plus minus 1. Here delta L will be minus 1. And here the value of J is 4 and the value of J is 3. So here delta J is minus 1. Here the value of J is 4 and J 3. So 3 minus 4 is minus 1. So that is your option number 4, option number first, which is correct answer. Okay, fortunately your option number first is the correct answer because it follows all these selection rules. Okay, rest of all option didn't follow the selection rule. That's why the right answer should be your option number first. I hope you understand it. Okay, so option number first is the correct answer for your question, for this question. Understand, friends? Okay, this is again a very simple question, friends. I hope you understand it. Okay, now we move towards our next question, and see, it says the populations of proton spins in the highest energy level of a sample in magnetic field of 1.5 Tesla and 7.0 Tesla and n dash and n respectively. The values of L and n dash over n is, okay, where gamma, h, k and t are gyromagnetic ratio of the proton, Planck's constant, Boltzmann constant and temperature of the sample respectively, and assume that the partition function for both systems can be approximated as 1. So friends, here you must find the value of L and n dash over n. Okay, and this question is coming for 4 marks. So let's do the solution of this question. This is a 4 marker question, friends. Okay, now first of all we have a formula for finding population of state. We have a general formula for population of state. So population of state is given by 1 by q e to the power minus gamma h b upon 2 kt. E to the power minus gamma hb upon 2. It is a general formula for population of state. Okay, and we have a two population of state. One is n and one is n dash. Okay, so for n dash it will be 1 upon q e to the power minus gamma h b dash upon 2 kt, and for n it will be 1 by q e to the power minus gamma h b upon 2 kt. Okay, and here q is the partition function which is equals to 1 in both cases. That is given condition in your question. Okay, so partition function q is equals to 1 in both cases, that is in the case of n dash and in the case of n. Okay, in both cases. Now you must find the ratio of n dash and n. Okay, so ratio of n dash upon n is equals to c. Uh, the value of 1 by q is 1, so it will be cancelled out. Okay, so it will be e to the power minus gamma h b dash upon 2 kt into gamma h b upon 2 kt. Okay, now here you clearly see that gamma h upon 2 kt is a constant term. Okay, so n dash upon n is equals to e to the power minus gamma h upon 2 kt into b minus b dash. Okay, because this is a minus term, so b minus b dash. Understand? Okay, this is a very simple calculation, friends. Now we have values of b and b dash in our question. Okay, the value of b is 7 tesla and b dash is 1.5 tesla. See in the corner, friends, we have a value of b and b dash. B is equals to 7 tesla and b dash is equals to 1.5 tesla. So b minus b dash is equals to 5.5. Okay, so according to our question, the value of b minus b dash is equals to 5.5, because b is 7 and b dash is 1.5. So 7 minus 1.5 is 5.5. So from this equation we get that n dash upon n is equals to e to the power gamma h upon 2 kt into 5.5. Okay, friends. Now take natural log on both sides. So when we take natural log on both sides in this equation, we take natural log of both sides in this equation. Okay, so e to the power converts into normal gamma h upon 2 kt into 5.5. Okay, so from this equation ln n dash upon n, which is this should be found in our question. Okay, ln n dash upon n. So ln n dash upon n is equals to 5.5 gamma h upon 2 kt. So the ratio of ln n dash upon n is equals to 5.5 gamma h upon 2 kt. Understand, friends? Okay, and this is your option number first. See in the corner, friends, your option number first is the correct answer for this question. Okay, I hope you understand it. See once again the whole solution. This question, the solution is based on this formula, that is the population of state. When you know the formula, you will definitely solve this type of question. Understand, friends? Okay, now we move towards our next question, and see it says the Burgess spawner plot between delta G nu plus half is equals to E nu plus 1 minus E nu and nu plus 1 for CO, that is carbon monoxide, is a straight line with slope of minus 14 centimeter inverse and intercept of 2170 centimeter inverse. The approximation value of dissociation energy of carbon monoxide in centimeter inverse is. Assume carbon monoxide as an harmonic oscillator with the energy expression is as given. Okay, and the formula for dissociation energy is omega upon 4xe. Okay, friends, and this question is coming for 4 marks, and this is based on your Burgess spawner plot. So let's do the solution of this question. Okay, so friend, this question is asked for 4 marks, and fourth number question. Now first of all, we have a straight line plot in between delta G and nu plus 1. And the slope of this graph will be negative, that is minus 14 centimeter inverse. This is a graph, actually this is a Burgess spawner plot. Okay, Now according to our question, we have a value of delta G nu plus 1 is equals to e to the power nu plus 1 minus e into nu. Okay, the value of delta G nu plus 1 is e nu plus 1 minus e nu. Okay, now in our question we have a value of e nu. See in the corner friends, we have a value of e nu which is equals to nu plus 1 by 2 into omega minus nu plus 1 by 2 square omega xe. Okay, this is the given value in our question. So from this value we also conclude the value of e nu plus 1. You just add plus 1 in this whole expression. Okay, so e nu plus 1 is equals to nu plus 3 by 2 into gamma minus nu plus 3 by 2 to the square omega xe. Okay, you just add plus 1 in this expression, so we get the value of nu plus 1. Understand? Okay, we only add plus 1 in this whole term. Okay, so we get the value of e nu plus 1. Now place the value of e nu and nu plus 1 into this expression, that is delta G is equals to e nu plus 1 minus e nu. Okay, so from this from these expression, the value of delta G nu plus 1 will be equals to e nu plus 1 is nu plus 3 by 2 omega minus nu plus 3 by 2 whole square omega xe minus nu plus 1 by 2 omega, and this will be minus and minus will become plus. Okay, so plus nu plus 1 by 2 whole square omega xe. Okay, this is the whole expression. So when you solve this expression, we get delta G nu plus 1 is equals to omega minus 2 omega xe nu plus 1. When you solve this whole expression, we get the value. Here we write the direct value, that is delta G nu plus 1 is equals to omega minus 2 omega xe nu plus 1. Okay, now you compare this equation with the equation of straight line, that is y equals to c minus mx. When you compare this equation with straight line equation, we get a curve between delta G nu plus 1 and nu plus 1. Okay, when you compare this equation with straight line equation, you get a curve between delta G nu plus 1 at y-axis and nu plus 1 at x-axis, which is given in your question. See carefully this. Okay, and the slope of this curve will be 2 omega xe. Okay, minus 2 omega xe, the negative slope, which is minus 14 centimeter inverse given in your question. Okay, and the intercept is equals to c, which is omega. Okay, which is also given in your question, that is 2170 inverse. Okay, so from this equation, the slope of the graph will be equal to minus 2 omega xe, and according to your question it will be minus 14 centimeter inverse. So this minus will be cancelled out by this minus. Okay, so from this equation, the value of omega x is equals to 14 by 2, which is 7 centimeter inverse. Okay, the value of omega x, and the intercept is equals to omega according to this equation, and according to our question, the value of intercept should be 2170 centimeter inverse. Okay, so the value of omega is 2170 centimeter, so the value of omega x is equals to 7 centimeter inverse. Okay, so from these equations, omega x is equals to 7 centimeter inverse, omega is equals to 2170 inverse. Place the value of omega in this omega xe, so we get the value of Xc. So X is equals to 7/2170. Understand? When you place the value of omega in this equation, this will be 2170 multiplied by X is equals to 7 centimeter inverse. So X is equals to 7/2170. Okay, understand? Now in this question we have a value of dissociation, we have a formula of dissociation energy, that is omega by 4xe, omega by 4xe. So place the value of omega and xc by these equations. The value of omega is 2170 and the value of x is 7/2170. Okay, so the dissociation energy of CO will be, see, the 2170 upon 4 into 7/2170. Okay, and when you solve this equation you get your answer. So the answer should be nearly equals to 168,175 centimeter inverse, which is your option number 3. Okay, when you solve this expression, the dissociation energy of CO on the basis of Birch-Sponner plot will be 168,175 centimeter inverse. That is your option number 3. Okay friends, I hope you understand it. See once again the whole solution of this question. This is a direct formula based question friends. Okay, सो फ्रेंड्स ये थे आपके कुछ क्वेश्चंस जो जून 2019 में फिजिकल स्पेक्ट्रोस्कोपिंग टर्म सिंबल टॉपिक से पूछे गए थे. आई होप आपको समझ आए होंगे. फिर भी किसी भी तरह की डिफ़िकल्टी आती है तो कमेंट सेक्शन में आके ज़रूर पूछिए. सो थैंक यू फ्रेंड्स, थैंक यू फॉर वॉचिंग.